Hello, you absolute legends. Consider this balanced chemical reaction here. We have H2, hydrogen gas, combining with O2, oxygen gas, reacts to produce water, H2O. And this is already a balanced chemical reaction with a 2-to-1 ratio for the reactants to produce 2 equivalents of water here. Now, if this chemical reaction is balanced with respect to mass and energy, and it's also very powerful in its predictive capabilities. If I have 2-to-1 ratio, I'm pretty confident that this is going to be produced here. But what if I have a 3-to-1 ratio, or a 4-to-1 ratio, or a 3-to-5 ratio of hydrogen to oxygen? How many waters are going to be produced? There's 2 ways we can answer that, and one is very graphical and one is very mathy using scaffolds. So let's start with the graphical method first. And let's get out there that say we have 5 equivalents of H2 and 3 equivalents of O2. How many waters could be produced? So let's imagine this in a vessel, a large container. And we're gonna have one container with the oxygen and hydrogen mixed together at the beginning. So we're gonna have a before container and then an after container. So in the before, at the very beginning of the reaction, there are 5 H2s present. So I am going to put those 5 H2 molecules of gas displaced in the container as a gas would. Gases fill their spaces. They're, say, relatively far apart from each other. So here's my 5 H2s. Now there's going to be 3 O2s in here. And there are my 3 O2s. Now with this graphical or cartoon method, I want you to imagine that these molecules are buzzing around like bees. They are moving in straight lines until they either hit a side of the container or another molecule. What's going to happen when something happens where these, say, all 3 collide in one place at the same time with enough energy to form a reaction? Well, if H2, H2, and O2 collided and they formed a water molecule, the after would look like H2O. So H2O. So that's an equivalent. If the water was produced, 2 hydrogens and an oxygen had to be consumed or used up. So that's the before. Here's the after. And H2O. So this kind of checks and balances is just meant to graphically show how when molecules collide, what could be produced. Now, these are not structurally accurate. These are just meant for tallying or keeping track. 2 hydrogens, oxygen, 2 hydrogens, oxygen. Could happen again. Up here, this hydrogen and oxygen, they could collide with each other in a water, H2O, could be produced. This hydrogen, H2, could collide there and produce another H2O. And then finally, we have H2O tallied up here. So in this graphical cartoon method, we could predict that when we have 5 equivalents of one thing and 3 equivalents of the O2, using the information from what our product is going to be, there could be up to 5 water molecules produced. Now, I said there was a mathy way to do this using the scaffold. So let me show you that scaffold method as well. So that is our answer there, that 5 H2Os could be produced theoretically. We have 5 hydrogen gases and 3 oxygen gases. Let's look at the balanced chemical reaction for a second here and look at these large numbers in the front, these coefficients. So when we have H2 and we want to predict how many waters could be produced, we have a 2-to-2 ratio. When we have oxygen to water, it is a 1-to-2 ratio. So these ratios of 1-to-2 and 2-to-2 we can write as fractions. This fraction here for H2 this is a fraction that shows us the product, what we're looking for with respect to the reactant from the balanced chemical reaction. Note the kind of color scheme I have set up here. And then identically, the ratio of the product H2 with respect to the other reactant O2. Now these 1s and 2s are fixed because of the balanced chemical reaction. And I have them all in purple to kind of show that out there. Now there is a scaffold way to solve this, where we take our experimental or what we have available in our stock room to try to predict what could be produced. Now with any scaffold, we want to cancel out the words or units we're not interested in and have only the words and units we're interested in remaining in the top of the scaffold. So 5 H2s are what's in my stock room that I use for the reaction here. And that's placed up on top, so that way the H2s cancel out. And when I calculate this out here, I have 2 times 5 divided by 2. That comes out to 5. And H2Os. Now this number here matches what we got with the graphical method here. But note that with this scaffold here, we only took into account the H2s. We do this one here that accounts the O2s. And then we compare our 2 answers here. For the O2s, we have our ratio from the balanced chemical reaction, a 2-to-1, 2-to-1. And we did this reaction with 3 equivalents of O2. So 2 times 3 divided by 1 is 6 H2Os. Now we have 2 answers from different scaffolds, and we know that this one is correct because we solved it with that graphical method there. Why is this one a wrong answer? Go ahead and rewind the video, and you'll note that at the end of that graphical cartoon method, we had an extra oxygen dangling around. And this scaffold is only taking into account the oxygens. Both of these reactions here take into account, this one only takes into account the hydrogens, and this one only takes into account the oxygens. To recognize that this is the best answer is because it is the lowest answer. When we do more of these predictive calculations and we compare two reactants, the lowest answer is the best answer. I hope this helps. Thank you.